Hey, what's up, guys? This is Chung. So let's take a look at today's daily challenge. Now, 1657. Determine if two strings are closed. So you're given like two strings, right? And you need to check if those two strings are closed. And those two strings are considered closed if you can attain one string from the other using the following operations, right? So the first one is you can swap any two existing characters. For example, you can swap this B and D with E and B. So what does this first operation tells us? Telling us basically it's telling us that you can rearrange the string freely. Since you can swap any two characters, you don't need to worry about the order of one string to the other because you can always rearrange the string to match the other one. The only thing we need to make sure is that the the letter the letter that appears in those two strings should be the same. And the second one is that the frequency of each letter also needs to be the same. For example, right, if we have two A's, if we have two A's in the and the three B's and four C's in word one. So to satisfy the first operations, we also need to make sure the second word also has like 2A, 3B, and 4Cs. So right, so that's the only thing to we need to check because since uh, we can swap any letters freely, so the sequence doesn't really matter. All we need to care is that the key or the letters appears are the same, and each letters have the same frequency. So that's the first operation. And then we have a second operation here. So which means it's saying that you can basically swap. You can transform, right? One occurrence for one existing character into another one. So for example, this one, you can swap all A, all A's to B, and meantime, you also need to swap all the B's to A's. So which means that, for example, if the first string has like this kind of frequencies, you can swap those two letters. So after swapping, we will have like three B's and two A's, right? And then you can keep swapping because you can do any of the operations as many times as you want. So then maybe you can swap this A with C, right? Then you will have like 3B, and then we'll have like A will have 4, and then C will have 2. So since with the second operations, the we cannot constrain the frequencies for each letter, but still, right? I think you guys can see that, but the first one, the first condition still holds, which means that, the letters, the letters appears in both words has to be the same. If we have, so we have A, B, C, right? So if on the second word, if there's like a D in the second word, so that obviously there's no way we can transform the word one to word D because there's no way we can make change any letters to D, right? And the second one is that we also since we can transform between two letters, so which means that we also need to make sure that the frequencies, all the numbers in the frequencies, they are identical, right? So it means that let's say in the first word we have 2, 3, and 4, and in the second word, right? First we need to make sure that we'll only have like A, B, and C uh, appears in the second word. And then the second condition is that we also need to make sure the frequencies has to be the same as this 2, 3, 4, but sequence the order doesn't really matter. Like I said, since we can swap two frequencies of the two letters freely, so it doesn't really matter if this is 3 to 4 or 2 3 4 or 4 to 3. As long as those three numbers are identical, we are sure that we can always uh, transform the word 1 into word 2. Okay, cool. So now the problem becomes much easier, right? So all we need to do is that we just need to get all the keys from the first word and all the keys from the second word, and then we compare if the keys are the same. Sorry, when I say keys, I mean the letters, because I'm going to use a dictionary to store that. And the second one is that we also need to get the all the frequencies for each letter, for each key, for each letter, and then we compare if those frequency numbers are the same. Cool. So to coding, right? So I'm going to use like a counters in Python, right? Basically, this counter function. This one will return a dictionary here, where the key is the letter in word one, and the value is the frequency of that letter. Similarly, for count two, we have a counter dot word. Okay, and then we need to get the keys one. So it's going to be the sorted, right? Count one dot keys, right? So this keys method will give you a list of the key. And the reason we're gonna sort it is it's easier for us to compare, right? Since we need to compare each element are the same, right? So by sorting it, then it's easier for us to do the comparison. So similarly for this one, sort keys two. After sortings, right? So this, let's say we have 2, 4, and 3. So this will become 2, 3, and 4, right? And then also, if we have like another one, like 4, 3, 2, this will also become 2, 3, 4. Now it's easier to compare these two these keys, the list of two keys. And similarly for the values, right? The values, which means the frequency, right? For each of the letters. Yeah, and then similarly, we're gonna do a sorted of the count one dot values, right? And then we have that's gonna be a values one, and then we have values two, right? Sorted count two dot values, and we just need to return if the keys one is equal to keys two, and the values one equals to the values two. Yep. So uh, oh, here word two. Yep. So yeah, that's it, right? So and for the yeah, for the time and space complexity, right? And so we have a 10 to the power of 5, and word 1 and word 2 contains only the English letters. So to do the counters here, so we have a O of n here, right? To count. And here we have sorting, but since the keys, right, the elements in each count is up to 26, right? Because the key can only be from A to Z. So to sort this one, so here is actually the O of 26. It's like the constant time. So the sortings won't affect our like time complexity. So the time complexity is O of n, and space complexity is also O of n, because we need this uh actually the space complexity is not O of n, because the dictionary, right? So both the dictionaries and the list. So the length, they are both bounded to the to 26. Yeah, because we will have will since we there will only be 26 English letters, so the count and the keys and the values, they're all like at maximum 26. So for the space complexity, it should be 01. Yeah, cool. I think that's pretty much it is. All right, so it's pretty straightforward, like the you can call it a greedy or string problem. You just need to compare, realize that the what does this two what do these two operations mean, right? So the first one means that we can the order doesn't really matter. The second one means that actually uh, it doesn't have to be the same frequency for the same letters, right? So as long as the frequency numbers are the same and the letters are also the same, then we can just always transform one word from to the other. Yep. So I think that's it. And thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.